In this video, we're going to talk about integration techniques and its application, mainly finding area and finding volume. So in an exam, this topic in particular, it's extremely heavily weighted. You will get one question on volume, you may or may not get one question in area, but trust me, these questions are extremely heavy. Some of them are 5 marks, 6 marks, and if you get them correct, you will just jump up by 1 grade. As long as you do these questions in a systematic order, you usually have no issues getting the full credits for volume and area questions. So let's take a look at first question. This question I have chosen because the first part asks you to find area, then the second part they ask you to find volume. One question to show you how to do this the most efficient way. To find area and volume, there's only two formulas each that you have to remember. Nothing very difficult, just minimize your decision making, just focusing on this. So these two I have written, integrate y dx and integrate x dy would be to find the area. Later I will show you how to do. And to find volume, there's also only two formulas that you have to remember, which is this, or integrate x squared dy. You don't have to work very hard to memorize these because it's really just this easy. Integrate y dx, integrate x dy, pi integrate y squared dx, pi integrate x squared dy. These two items here in green are the axis that is in focus. So if you are doing it with respect to the x-axis, for example, this question, if I'm integrating this green graph with the x-axis from this point to this point, then I'll be finding this area. So we will use dx if you're interested in using the x-axis. If you are using the y-axis, we will use the second formula here, integrate x dy. So same thing, same green color graph. If we were to do with respect to y, we will need y values, and we are using it with respect to the y-axis. So the area you're finding will be this. Of course, you have to fill in the boundaries here and here yourself. These are items that you have to fill in based on the question. So for example, this is from 2 to 7. Then you fill in from 2 to 7 with respect to y. Now what do you fill in for this x? X, you just have to follow the formula. So in this case, y is the subject. You actually have to make x the subject. Then you put it in. Later I will show you what I mean. So let's move on with the first question and see how we can use these two formulas. So first question, they say this equation is y equals to something plus 3. So y is in terms of x. They're very nice. They give you every single point that's available. Like this is root 3. You don't have to find it yourself. Very good. Calculate the area of region R. So they want this region here. So taking a look at this, you can use either of this. They are just different means to the same answer. So let's say we really want to use this. We really want to integrate with respect to y, meaning I need to go from here to here. The area between the y-axis and the curve. So that will actually find us r, right? First thing, you need to find out this point. This point here is 5. This point here, you have to go to your formula and you find out what is the y-intercept. In other words, find out what's the value when x is 0. So y equals to 2 over root 4 plus 3. This will be 2 over 2 plus 3, which is just 4. So you'll be choosing this formula here because I'm integrating with respect to y. I'm using y-axis as your basis. So integrate x dy from where to where? From 4 to 5. What is x? You have to make x the subject. So we have to go through this process, turning x. So y minus 3 equals to 2 over this. So I'm going to put the 2 over, this will give us root 4 minus x squared. Then I'm going to square both sides. And then I'm going to bring x squared over, and this to the 4. I'll get this. 4 minus 2 over y minus 3 squared. And then I'll square root both sides to give me plus minus. Which one is it? You have to reject one because the curve usually looks like that. You have to choose the right one. This is on the right hand side. So therefore, x values are all positive. You don't want the negative one. So you put this, squeeze this inside here, and we do the integration. Once we are done with that, we will get the answer. So this is square root 4 minus 2 over y minus 3 square dy. So you have a clean equation in y, you integrate with respect to y. Luckily for this question, they say calculate the area. So you're not expected to do this by hand. Just use GC, put this into your GC, and you'll get an answer that is in 3dp. However, sometimes you notice that this is actually pretty hard to integrate. I have no idea how you're going to integrate this by hand. Sometimes it's just not doable at our level. Sometimes we are forced to use the alternative formula, which is this one. So take a look at this question and we think about it in another way. Let's say I want to find the exact same area. Instead of integrating with respect to y, for this curve, we can actually find this purple color space, then take this entire rectangle, then we minus away the purple color space to give the exact same green color space that we are looking for, right? So to find the purple space, all we have to do is to integrate y dx from 0 to 3 using the x-axis, right? Because we are integrating with respect to x. So 0 to root 3. This time around, y is very convenient. You don't even have to do any manipulation. Just throw this in. So 2 over root 4 minus x squared plus 3 dx. Once you find the purple area, you can just use the rectangle, which you can find by doing length times breadth, 5 times root 3, and then you subtract it away, you will get a green color area. Both of these will give the same answer. So here I have keyed this gray color formula into the calculator, and we found out that the answer is 1.3697. 1.37. Now to find the purple one, it will be 7.29. Okay, don't worry, this is not the final answer yet. It's just that the purple area is 7.29 units. So let me take that down. 7.29. Then remember, to find the green, you have to take the entire rectangle minus the purple one. So it's actually 5 root 3 minus 7.29. 5 root 3 minus this previous answer. Take a look at that. It's the exact same number we get, right, from integrating with respect to y, 1.37. So here, the learning point is there are two formulas you use based on which axis you want to use. The foundation is exactly the same. It's just this template. Fill in the correct boundaries, use your own logical approach to find the space that is required, and reduce the question to just a simple integration. And if the question never say find the exact value, just use GC. Why we have two formulas to find the same exact green area is because sometimes they want you to do it by hand. Yes, the easiest way to do this green color area is obviously going from 4 to 5, use the y-axis and integrating it with respect to y. That will give you the shortest possible method. However, the integration here, you realize, is rather difficult. If they say find the exact one, this will be a nightmare to integrate. At least for the purple one, this becomes a sine inverse. So yes, it's hard, but it's still doable. So this is why you have to be flexible in choosing which area formula to use. Now let's take a look at the second one where it involves volume, and then we will use these two formulas here. Before we actually attempt this question, let me just talk a bit about the two formulas that I wrote on top, okay? Two volume formulas. They are finding different things. Remember, this green box here tells you which axis I want to use. Think of this as roasting a chicken, okay? You have the stick, and then you have the chicken on top, and then you turn it, and then the fire is below, right? You're roasting the chicken. Same thing. Think of this as the metal rod. This means that the y-axis is the metal rod, okay? And then you are spinning this chicken around 360 degrees. And this one, x is the axis, and then you're spinning it this way. So this blue color graph will spin this way. They are finding different things, huh? So let's take a look at what kind of shape it will form once you rotate them. Let's take a look at second one first, which is this graph, using y as the axis of rotation. So once you have filled in your x squared, which is making x squared a subject, and you're throwing that inside here, choose the correct boundaries, in this case, which is 4 and 5, what kind of shape will we get? We will get this shape. You will get a 3D figure that looks like this. It's like a bow. So this red color is the resultant shape you will get. It's like this kind of shape. And let's take a look at the first equation. What kind of shape will we be getting if we spin the y square with respect to x? What you will get is actually, because this is the area we're looking at, then what you will get is you will get this. You will get this shape here, this peach color shape, which looks like that. It's like a vase that is tilted horizontally. Two different formulas giving you two different volumes, depending on which is your axis of rotation. Here, this question says, by considering a suitable translation, show that the volume of the solid when R is being rotated about this line now. The issue with this question is your axis of rotation is neither the x or the y, right? So this is why they ask you to do a suitable translation. In order for you to rotate this with respect to this line, we have to shift the curve down and turn it into a graph that looks like that. So that this pink color line is now this pink color line here. And then the graph will look correspondingly like this. We want to shift 5 units down. So this used to be 4, right? So now this number now is 0 and this value here is -1. But however, we are not going to spin it this way, right? So these values are not important. We are not using the y-axis as the basis. We are going to still use the x-axis because that's what they say. Rotated completely about the line y equals to 5. After we shift down, we are rotating it about the x-axis. Meaning the x values are the one that's important for the boundaries. Luckily, they remain the same. This is √3, this is 0. So the formula is just integrate pi y square dx because x is the axis of rotation. Remember the barbecue stick idea? Before that, let's shift the curve down. Thinking back, remember what you learned in the topic of translation? We want to shift the curve down vertically, so we have to replace y by y plus 5. Once we have done this, we will be shifting the curve down. This will create this y plus 5 equals to 2 over root 4 minus x squared plus 3. Y would now be 2 over root 4 minus x squared minus 2. Because we bring the 5 over to become minus 5. This would be the formula that we will be squeezing inside here. What about boundaries? Boundaries is just 0 to √3. Once we've done that, simplify this to get 2 over root 4 minus x squared minus 2 whole thing square dx. Simplifying this should give us this. So let's just simplify this. Pi √3. Expand this, I will get 4 over 4 minus x squared minus 2 times of this times this, which will give us -8 over root 4 minus x squared plus 4 with respect to x. Pulling out 4 would give us 4 pi, 0 to √3, 1 over 4 minus x squared minus 2 over root 4 minus x squared plus 1 dx. Exactly what they want us to show here. So now we are done with the showing part. Now do the integration and evaluate it. Sadly, they want it exactly, right? Meaning you have to do this by hand. This would become 4 pi. This one, just turn it into a 2 square and then use your MF26 to give you 1 over 2 times 2 ln of 2 plus x over 2 minus x. This one, once again, turn this into a 2 square. This would become a sine inverse, which is -2 sine inverse x over 2. Integrate 1 will give us x, evaluated from 0 to √3. 4 pi on the outside. Here you will get 1/4 ln 2 plus √3 over 2 minus √3 minus 2 sine inverse √3 over 2. Sine inverse root 3 over 2 gives us pi over 3. So this is negative 2 pi over 3 plus root 3. Minus away, sub in 0. Here I will get minus away 1/4 ln 2 over 2, which is ln 1, which is just 0. So I'm not going to write anything here. Put in 0 here, sine inverse 0. It's still 0. So that's 0. This 0. Put in 0 here. Also 0. So that's it. Case closed. Multiplying the 4 pi. Actually, you don't really have to. You can leave your answer like that. That's good enough. Just a point to note.